Okay, and so here we have f of x equals 7. Do you recognize that function? This is a line, isn't it? And if you recall that f of x is replacing the letter y, we have here y equals 7, and that's our constant function, right? That is our horizontal line. So constant function, horizontal line. So I just want you to keep that in mind. Okay, but process is the same. So now we're going to do f of a. Okay, but you're going to say, but you know, there's no like x for me to put a into. You're right. So f of a is just 7. Okay, and then we're going to do f of a plus h. And you're going to once again tell me, but there's no x for me to substitute a plus h into. You're absolutely right. F of a plus h is 7. That's why it's called the constant function, because no matter what I put in here for my input, my output is going to be 7. Doesn't matter what my input is, my output is 7. So that means that the difference quotient is, and again, right, f of x, a plus h minus f of a all over h. So 7 minus 7 all over h, which is 0, divided by h, which is 0. So this is an interesting difference quotient. When you have a constant function, your difference quotient is 0. So our difference quotient is 0. And what other feature of a horizontal line do you remember is equal to 0? Well, if you set the slope, you're absolutely right. So one of the ideas that I want to leave you with is the idea that our difference quotient is a very fancy way of calculating slope. What's good about it is, and you will see this in your pre-calc and calculus courses, is that we can then calculate slope when we have graphs that are not necessarily straight lines.